We will be presenting the simulation and modeling using MATLAB of a single phase inverter. So basically an inverter is a circuit which converts a DC power into an AC power at a desired output voltage and frequency. The AC output voltage could be fixed or variable voltage and frequency. This conversion can be achieved either by controlled turn on and turn off devices, and in this circuit we are using IGBTs. The output voltage waveform of an ideal inverter should be sinusoidal, but practical inverters have non-sinusoidal waveforms which contain certain harmonics. The output frequency of an inverter is determined by the rate at which the semiconductor devices are switched on and off by the inverter control circuitry, and consequently an adjustable frequency AC output is readily provided. The harmonics content of an output voltage can be minimized or reduced significantly by switching techniques of variable high-speed power semiconductor devices. The DC power input to the inverter may be battery, fuel cell, solar cell or other DC source. In this simulation we are using a DC voltage source of 100 volts, and the working of the circuit will be explained by Madhurya.
The power circuit of a single-phase unipolar inverter consists of 4 bidirectional IGBTs arranged in the bridge form as shown in the figure. The input to the circuit is 100 volts DC supply from the rectifier unit. The IGBTs are triggered accordingly such that the AC output voltage is obtained at the output. The operation of the circuit is as follows. First, the IGBT S1 and S4 are turned on by triggering the gate of the IGBTs S1 and S4. During this time, the input supply is 100 volt DC at the output. The 100 volt DC is applied across the load. The current starts from the supply positive, goes to S1 through the load S4 and back to the negative. So this is the conduction path for the first cycle of operation. During the next phase or cycle of IGBT, S2 and S3 are triggered by giving trigger pulses to the gates of the IGBTs. During this period, the input voltage is applied at the output but in the negative direction. The current conduction starts from the supply, goes to S2, S3, the load, and to the negative of the supply. As the two cycles continue, the positive and negative voltage is applied at the load and the current direction changes in the two cycles. As the current direction changes, the alternative voltage is obtained at the load, thus converting DC voltage to AC voltage. Okay, now with the simulation we can see that the input is DC, which is converted to AC, which is yellow in color, and the input DC is purple in color. So thus so this is how the single phase inverter works. Thank you.